Now, factoring trinomials, 1, 2, 3 pieces in this trinomial. When factoring trinomials, we basically go back to two binomials. So the factoring of a trinomial makes binomials, two binomials, and two binomials multiplied together reverses itself, and it makes trinomials. So this is actually the go together step where you're multiplying, and this is the breaking apart. In the very first position and the last position, we get these two numbers via multiplication. The middle term we get through addition or subtraction. So I'll do addition or subtraction. So we need to be thinking of numbers that, when multiplied together, give us 1. But we need a squared term on this because the coefficient of a is, in this case, is 1. So we have to think of some number when you multiply it together, you'll get it squared, a squared value, but with a coefficient of 1. And that happens when we have an a in the first position of both of the parentheses. So if we multiply that together, a times a gives us a squared. So that's good. Then to get this number is a very telling one, because we've got to find numbers that would multiply together to get 12, but would add or subtract to a -7. So I like to use what I call this like little T guy here. And it's the factors of, this would be the factors of 12. So I'm methodically going to think of my factors in order. So I know that 1 and a 12 will multiply to give me 12. 2 works, 2 times 6. 3 works, 3 times 4. And 4 works, but I already have it. So I know that I've overlapped here. There are no other factors of 12 except the ones that I've listed. So in this position, this back position, I can use any of these combinations that will give me 12, but not all of those combinations will give me a -7. So I need to also focus on the signs here. Let me show you how it works though. If I add or subtract 1 and 12, I would get either 11 if I'm subtracting it, and if I'm adding it, 13. Well, that doesn't give me what I need. I need a 7. 2 and 6, if I subtract these, I'll get a 4. If I add them, I'll get 8. No. If I add these, I'll get a 7. If I subtract this, I'll get a 1. So I'm going to need to have 2 negatives on the 3 and the 4. So I'm going to have a -3 and a -4. I think I've done that correctly. Let's check it out. I can multiply this binomial back to see if I can find the original. So let's see. This is my check. A times a is a squared. A times the -4, -4a. -3 times a, -3a. Negative times a negative is a positive. 3 times 4 is 12. Does this match? Perfectly. The T-graph helps me organize my thoughts because I have to choose. They all made 12 when you multiplied them, but the telling one was this middle term that made me select the way I did.